Hello, programmers. Today we're going to be talking a little bit more about Coder's Basilisk. This is going to be the second tutorial. Here's the code for the second tutorial. It's only 140 lines of code and then some blank lines, right? So I guess they don't really count. So less than 140 lines, right? In this tutorial, you're going to learn how to use you're going to learn the basics of control flow and how it works. You're going to learn how to use malloc, and how to perform casts. You're going to learn about the two different ways, the two different syntaxes for a cast. You're going to learn how to use the switch statement, because the switch statement does not work like it does in C. This switch statement is a lot faster than the one in C. It's also a lot more dangerous, so you need to be careful how you use it. But it is worth it in my opinion. It's faster, so this is just a little demo here. Let me rebuild it. CBAS main. Oh, first of all, guys, there's something I need to show you. I forgot to do this in the last tutorial. You see here how my files are set up, right? .cbas_config and main.cbas. ed cbas. I showed you this last time, but what I did not explain is that this path right here is not relative to this file, or indeed to any of the files in the project. And the way I want to demonstrate this is I want to try invoking CBAS from a different folder, right, from a different position. If I run it here, it won't work, because it won't be able to find the main library. It also won't be able to find CBAS_config, right? So it can't find the... Okay, but anyway, and I want to further demonstrate this, let's make a temporary directory, Q, into Q, and we do cbas /main.cbas. It cannot find this file, and the reason it cannot find this file is that I called CBAS from a position where this path does not make sense, right? If we do /Coder's Basilisk, there is no such folder inside of here. All paths, as interpreted by CBAS in anything, right, are relative to where it was called, right? So if you try to compile a project and it doesn't work, you need to try to compile it from the proper place. And the way that you can try to figure that out is you can look at the directories that it gives, right? So you can see here, if we imagine that we downloaded this project from the internet, right? And we want to figure out how to compile it. Imagine that there's a bunch of folders and stuff, and we don't know where to call CBAS, right? If we look at the CBAS_config, first of all, that file is always going to be in a directory where CBAS is going to be called from, right? So you can obviously tell that. But also what you can do is you can look at where the includes, right? If there are any includes in the thing that are like this, right? If .h, so imagine that there's a bunch of files. My folder / if you look where the directory where my folder is, that's where you're going to call CBAS, right? If you download a project from the internet, you don't know how to compile the project, you can look for where the includes seem to be coming from, right? What directory they seem to start in. And that'll tell you where you need to call CBAS. Right? So if you try to compile one of these projects and it doesn't work, try checking the directories and make sure that everything's set up right. Because as I said, right, this is not like C. It works from the place that you called it, right? The current working directory. But anyway, let's build this program real quick. I just did a little bit of testing. I can't guarantee that it's bugless, but it seems to work. This is a linked list demo, okay? We can insert an integer. Let's insert a position 0. Let's enter the value -1. So insert another integer at position 1, value of 0. Insert an integer. Let's insert at 1 again, and let's enter, 46. So now we've inserted some things. Let's try deleting some things. Let's delete the 46. Let's insert an integer, position 2. We'll enter the value 1. All right. Let's delete the head. Hold on, we did the wrong thing, right? Okay, so we're gonna have to delete twice. 0, 2 for delete, we want to delete the head now. Okay, now we just have 0 and 1, right? Okay, so, you know, and you see that it's also a little bit robust, right? Just a little bit. 400, right? Position 400 doesn't exist. Let's try entering a value, 99. Obviously, just inserted it onto the end, right? So anyway, this is just a quick little demo of a linked list, right? And it works by, you know, just, you know, it traverses the linked list every single time. It's not a doubly linked list or anything. So the first thing I want to point out here is, first of all, the way that we start the program. The program starts here at main. I did not explain this last time. This is another thing I failed to explain in the Hello World tutorial. But this word pub right here is very important. It's short for public. Let's exit this. Right? If we do CBAS-M index, there should be a list here of all the, there might not be, I might have forgotten. There's a list of keywords that might be there. So there's a whole bunch of modifiers, right, that you can apply to global symbols, right? Pub is one of them. Basically, if we go to auto-out.c, right, and we go all the way to the bottom, you can see here that main is declared int, and there's no static or inline or anything like that. But if you scroll through here, most of these functions are declared static, right? These functions here, they're declared static, and the reason that they're declared static in the C code is that in the coder's Basilisk code, there's no modifiers at all, right? So the reason that I made it this way is because most of the functions in coder's Basilisk, I imagine, are going to be local to the compilation unit, right? You don't want to accidentally expose symbols, you know, to the. Hold on, I was looking at that. You know, so these variables right here that we declared, these variables are not exposed to any other compilation units, right? We can declare one of them pub. So I think. I don't remember. Do we do it here? I don't remember exactly. And it's still working. So reload the file. Right now that we've declared line position pub, now it's no longer static. Right. Hold on. Oh, this is hello world. Because we've declared this pub, it is now visible to other compilation units, right? And the main function must be declared public, right? Which, if you see here, pub and public, right? That, there they are. I believe private might also be a keyword. It's like one of those things that you never need to actually type. Maybe not, maybe not. These are the aliases for FN, right? We could write procedure. That's totally valid. Let's just confirm that. Or we can use proc. This should still compile. Yeah, it does. Yeah. And main looks exactly the same, right? So basically, the way that you declare functions is very important. You can apply various modifiers, including atomic, that I don't believe can be applied to a function. You can apply pure to a function, right? Which basically says that it can't touch any global variables, and it must only call other pure functions or pure methods. Atomic, right? That's say of a global variable, and only of global variables. By the way, you can't apply atomic to local variables. Of a global variable, and if a global variable is atomic, then any modification of it, any assignment or read of it will happen atomically, right? It can't be interrupted by another thread, right? And you know, it basically just turns into an let's compile with atomic. Let's just look at what the code does. So now you see it's declared _atomic, right? Which is how you do atomic variables in C11, right? with the C compilation target, and it still works. Yeah. See, and we can delete one. Yeah, here we go. Right, and it still works. Right. So atomic, right, is something that we can use to. This is useful for threaded applications, basically. Yeah. But anyway, so that's that, right? It's important that you keep in mind how you declare your variables, right? And how you declare your functions and stuff, and what modifiers you put on, right? I'll explain more of these later, right? But let's go back to the program. First of all, we declare a struct. By the way, let me just show you guys something. The no export word, right? I didn't properly explain this either. If I put no export in here, now it won't work because the LL node type is not defined, right? Type decals, right? It has type stir, pstir, but there's no LL node, right? If you want to declare code gen types, you use no export, right? And also, obviously, if you'd want to declare methods or functions to be code gen, you use the code gen keyword. But for structs, you use no export. Now this will work again. Yeah. And now you can see LL node is now defined, right? We can properly space this out. You know, the LL node type is defined now because it's not no export anymore. So we define the struct LL node. We define a constructor and a destructor. In this case, the destructor actually does nothing. If you create a constructor, I recommend for use with other code in the standard library that you always create a destructor. The code that I wrote for containers assumes that if a constructor is defined or a destructor is defined, then the other one is also defined. Also, of course, if you wanted to, you could declare a function inline. All right, let's recompile this. You know, and let's see what it was. Print. It's declared inline now, right? Which means that the compiler is going to insert it into anywhere that it is called. And since it's only called once, it's actually a pretty good idea, right? So because if it's only called ever once, then it should probably only be used once. Keep in mind that if you use inline, you probably shouldn't use public. In fact, I think that's actually an error. Should be. Is it not? It's not. Interesting. Oh yeah, see, but it'll be an error when you compile it in C, right? So if you declare inline, you should not use public, right? I'm surprised I did not make that an error in the CBAS compiler. But anyway, we will actually define this as inline as an example. I'm just explaining here a couple things about how to declare functions that I did not explain last time. Can't promise that the linked list demo is bubbleless, but we're going to go through it anyway, right? Anyway, so this is the LL node struct, right? This is something that you might write in C. You've probably seen this before. I expect you to have seen this before. This is a constructor and destructor, right? If we look at the constructor and destructor, here's the constructor function and the destructor function in the compiled code. Here's CTOR and DTOR. Right. As you can see, the way that Coder's Basilisk creates constructors and destructors is it just defines a function with this really weird name, right, using 5 underscores. That's special in Coder's Basilisk. Anything with 5 underscores in it is an illegal name for you to write. You're not supposed to use that unless it's part of a library and you're like trying to make names that user code should not write, right? It's 5 underscores in a name equals the library is supposed to be it's library code, right? And libraries are supposed to be smart and know how to not interfere with each other. And two underscores at the beginning, right? Or an underscore at the start is also another signal that it's part of a library, right? This is convention, right? And then here's the body of CTOR, right? Which we see here. Let me make the text big. It's just the name mangling makes lines super long. And it's just calling memclear here. And it does all this casting here because it basically because everything involves tons of casting, right? This is the constructor, this is the destructor. Here's the head of our linked list. This is a function to print our linked list. We just count through, we have an I counter, and that allows us to print out the numbers, right? The positions. And then we print out the value. And then we do c.next, right? The I++ here. This should be very obvious for you C programmers. Here's how we insert into the linked list. First, we malloc a new node, because we always are going to malloc a new node no matter what when we're inserting. We're going to call a constructor on it, because that's a good thing to do. We're going to set its value to value. If the head is 0, we just set it to be the head and return. All right. If there's no head, this thing has to be the head. If the position is 0, as in we're trying to replace the head, the new node's next will be the head, and the new head will be the node that we allocated. Right. This, by the way, is an if statement. You should be able to tell the syntax of an if statement from this. By the way, let me explain really quick how else if and else work, right? We could at fprint 47, hey, right? 69, haha. Else. A boring number. There we go. See, right, and this is a properly formatted if else statement. Right. Let's quickly compile this. Uh, 47, and we'll do value 0. Hold on, why didn't it? Oh, right, because I see. Okay, it caught this clause here. Enter a position. We'll do 47. 47. Hey, right. See now position 47 at position, and you see because it. And then what we do after this, right? Okay, now I've just done this here to demonstrate how if else works, right? No, by the way, I do want to quickly explain how this is parsed. The way that this is parsed, and I know we're jumping around, you gotta follow along with me, right? This is the format of if else. The way that this is parsed is that if always starts a new chain, elif always continues a chain. We could not have elif here, right? Because this is not inside of an if, right? This is inside of an if, so this is going to be the next thing, right? The way that this compiles to C, by the way, let's find the name of this, L insert, is as you'd expect. It compiles into an if, else if chain, right? And see that these if statements are clearly separated, right? Every single one of these creates a new scope. So anywhere that you have one of these little sections right here, this creates a new scope, right? Elif and else continue a chain, and they, So just keep that in mind. That's how that's parsed, if you're wondering. Anyway, this is LL insert, right? I hope I don't actually need to explain anything of how this works. If you see a bug, write a comment. This is deleting an element in the linked list. We capture if the head is 0, right? If there's no head, we can't delete anything. If the position is 0 and there was a head, then we, grab head.next, call head.detour, which actually does nothing here, but whatever. We free the head. And by the way, notice that we have to use cast a byte pointer. This is very important, right? Free expects byte pointers, and there is no void pointer type in Coder's Basilisk. So, there's no, and the typing is strict. So we have to explicitly cast to byte pointer in order to pass it to free. We set head to in, which was head.next, old head.next, and we return. Then what we do here is we walk, and we walk until we reach the parent of the node we want to delete. We've reached the parent. If there is no node to delete, just return. If there is a node to delete, we delete the node, and then we set our parent next to be the node after the one that we deleted, right? This is how we read a line, right? This is a quick demo of reading line input, right? If C is \n or \r or less than 0 or greater than or equal to 255, or line position is 1023, then just return, right? And then otherwise we collect the character, right? This is our menu inside of main, right? We do not parse the function arguments. I could demonstrate that, but if you're an experienced C programmer, you should know how function arguments, not function arguments, how command line arguments are parsed. I could write a demo of that, but you probably don't need that. This is declared I32 explicitly, but it's an int, right? This is schar pointer, right? Because in C it's char, and on this target char is signed, so we have to declare it schar, which in here, by the way, will be declared normal char. Right, here's the main function, char pointer. This is a flag inside of the 2C code generator, whether or not char is signed or not. It's important that you set that flag correctly. Here's the code of the demo, right? This is the code for the menu. This, by the way, is how you declare a go-to label. You write a colon followed by the text of the thing, right? And if you want to be extra special sure that nothing else before it is interrupting it, you can type a semicolon here. But the only time you ever need semicolons in Coder's Basilisk is when you have an expression. Any expression likely requires a semicolon, right? If there's a statement afterward and it's not a keyword, it doesn't start with a keyword. For instance, this statement right here, this expression, we could delete this semicolon and it's just fine because there's an if right here. Hold on, we're reading my link. This still works, So we actually didn't need that semicolon there, right? That's an important thing about Coder's Basilisk syntax. You only need a semicolon if there's an expression followed by anything other than a keyword. If there's a keyword here and it's not part of it's not one of the keywords that goes in an expression, like cast, then you can omit the semicolon. If the line is empty, we just reprint the menu, right? So if I just keep hitting enter, the menu reprints. If you type something funny into the line thing, right, like 0 or something other than a menu option, right, like J, K, L, A, any one of these will produce it'll just reprint the menu, right? It'll completely ignore it if it starts with something other than an integer character, between 1 and 3. Then it does a switch, right? And this is how the switch statement works in Coder's Basilisk. The switch statement works by jumping to a go-to label within the same scope as the switch statement. Not a parent scope, not a child scope. Must be in the same scope. For instance, if I wrapped this one here in an if statement, right? This will stop working, right? Because it can't find opt-ins. Aha, see? Now if we look at the error it gives us, switch statement in function uses label not in its home scope. A switch statement is not allowed to jump out of its own scope, either up or down. Function main. Label in particular, opt-ins, right? See, this label is not in the same scope as this switch statement now. Now we could, for instance, do this, right? And then we could have an empty scope right here. That's completely fine. right? So that's completely fine, right? And we can look at the code generated. So here's, it should, see, here's our empty if statement right here in the generated code, right? This if statement here is right here, right? And it generates no statements because there's no statements in here. I just put a semicolon in there, and that's not a statement. That's just the terminal of a statement. It just skips over it in the parser. Anyway, so this is these are the menu options, right? Let me indent them for you so they look nice. And opt exit is return, right? Let's space these out a little bit. So the first option is to insert an integer into the linked list. This is to delete an integer from the linked list, and this is to exit. And so what this main function is doing is it first goes and it runs the menu code, then it reads a line, it checks the line. If the line is nonsense, it prints the menu again and tries again. If the line is sensible, if it starts with an integer, 1, 2, or 3, it jumps to the correct option, right? Now, I could actually, for instance, add a case for if line of 0 equals q. Go to opt exit, and that would enable it so you could type q. Just as an example. Oh, wait, why isn't that working? Oh, you know what it is? Okay, that's why. That was a quite silent logic bug. Q is obviously not an integer between 2 and 3. Q. There we go. See, right. And now I've added functionality to this right on camera, right? It switches based on the first character of the line, -1, right? By the way, oh yes, something I need to explain about switch statements is that this is just an array. If we just look at the code here that it generates a dispatch table, right? What it's doing is it's using the GNU-C feature of hold on, where is this end? It ends right here. Okay. Right. So here's this is our expression inside of here. Right. This is that expression. If we look at it carefully, right? 49 ULL. If you look at an ASCII table, will turn out to be the character 1, right? This right here is indexing the line global variable, indexing of 0, right? And then we subtract the 1 character from it, which is extended out to an unsigned long, right? And then this goto statement references this dispatch table up here. I'm sorry for making the text so small. It had to be that small in order to get everything on screen. Right here, this is computed goto, if you didn't know. So basically, Coder's Basilisk's switch statement is just computed goto. And any time that you use the switch statement, it'll generate it'll use one of these things, right? Now, if I have multiple switch statements in here, right? Let's shove some extra switch statements in here, right? And I just want to demonstrate something for you. Switch statements with the exact same options will not produce duplicate dispatch tables, right? You see that we have multiple switch statements, but it only produced one dispatch table, right? Here's our duplicate switch statements down here at the very bottom, but there's only one dispatch table. If we change one of them so that it has a slightly different list, and I was very intentional there, by the way, about deleting the very last one. It doesn't matter which one you delete. It'll generate a new dispatch table, right? So you see here, now there are 2 dispatch tables. One that's insert and delete and exit, and this other one that's insert and delete. You'll notice that, logically speaking, we could reuse this one for this one, but we just don't do that, right? I just generate a new dispatch table for every single time that a different switch statement has a different dispatch list, right? And so that's that, right? That's how the switch statement works in Coder's Basilisk. And I believe that's basically everything I need to explain, right? This is how this works. Here's our code generator function. I explained that last time. Function cogen underscore main. We could omit these parentheses here, right? That's something I need to explain a little bit. Functions in Coder's Basilisk, when you call them, do not require parentheses if they take no arguments. If a function takes no arguments, then it can be called as if it were a variable. And the reason I implemented this originally was so that you could have constant global variables. Basically, a global constant that you can't modify. Because there's no const in Coder's Basilisk. However, I have extended this to work with methods, right? So these methods right here, they're declared like this. I could declare them like this, and it would work exactly the same way. I don't need to use parentheses. Right, I don't need to use parentheses in order to call this method here because it takes no arguments. By the way, ctor and dtor must always have no arguments, right? If I make this take arguments, it'll error on me. Object-oriented programming error. You attempted to define the ctor of the type LL node, but with an improper prototype. Ctor and dtor always take 0 arguments and return nothing, right? Similarly, if I try to make it return something, so let's say my pointer. Object-oriented programming error. You attempted to define the ctor of the type with an improper prototype, right? 0 arguments and return nothing, right? So you can't do it with dtor either. Should be an error. I'm actually testing my compiler just a little bit, right? The dtor of the type, right? And similarly, if you give it arguments, with an improper prototype, right? So, you know, ctor and dtor take no arguments. You can declare them with parentheses. That's not an issue. I know this is kind of rambling. I know this is maybe a little bit hard to follow, but I'm hoping that you're smart enough to follow me along here. If you find my explanation here confusing, you should be able to find this code. You should be able. I will upload this code to Codeberg. Let me. Let's git init branch -n main dot initial. Let's quickly create a repository for this. I'll upload this to create repository. We need to git remote add origin. We won't use HTTPS. Hold on. It'll be git at codebot.org/:gec. And let's remove .git at the end. This should push it to the repository. And so here is this code, right? In case you want to look at it and you want to compile it yourself. And you know what? I'll actually put the auto-out.c with it. This will give you the generated C code. Here's the generated C code in case you want to look at it and you don't have Coder's Basilisk set up. And this will give you an idea of how code is generated in Coder's Basilisk. Anyway, so I hope that this video gives you an idea of how Coder's Basilisk code is written at a very basic level, how to use the basic control flow structures, how to use constructors and destructors, etc., right? How to use malloc, how to use casts, right? The different ways you can call cast. I will explain a little bit later why cast is actually a keyword and why you would ever want to use this instead of just using this. But for now, this is how you cast something. This is the safer way, right? If you get weird errors, try using cast. And the reason that you might have an error is, for instance, if you have vec. Right? Imagine for a moment that we had vec, right? The reason, when it finds an @ sign, it doesn't know that that's the beginning of a type, so you have to use cast, right? Yeah. So anyway, so that's, I'm just throwing facts at you, right? You got to remember here. This is how Coder's Basilisk works. This is a simple program that just implements a linked list. Hope you guys enjoyed. Thanks for watching.